Welcome to the deep dive. Today we're doing something a bit different. We're zeroing in on a single unheralded hero of critical infrastructure.
Yeah, just one component. We're going through the datasheet for the NTI E-STSP-7 pipe temperature sensor.
And our mission really is to unpack why, a $131 piece of hardware is so fundamental.
Exactly. We want to look past the raw specs and ask what's actually built into this thing that makes it so reliable for these huge industrial systems.
Okay, so let's start with the basics. What does it actually do?
Well, at its core, the E-STSP-7 just measures surface temperature. It's designed to be mounted right on thin-walled pipes, steel, copper, aluminum.
The kind of pipes carrying critical fluids, I imagine.
Precisely. And it plugs directly into an NTI Environmux unit. For anyone listening, that's basically the central brain that logs all the data and, sounds the alarm if something's wrong.
Right. So let's get into the design. What makes it so tough?
So if you look at the specs, it's clearly engineered for some pretty hostile environments. We're talking about an IP65 weatherproof enclosure.
Which means
It means you can mount it outside, exposed to rain, dust, whatever, and it'll just keep working. Plus, it uses a solid copper contact.
okay, and that's for accuracy, right? To get a true reading from the pipe.
Exactly. It ensures a really clean, direct transmission of the surface temperature to the actual sensor inside.
Okay, but I have to ask. The datasheet says the mounting system uses adjustable cable ties. For something this mission critical, doesn't that sound a little flimsy?
It's funny you say that because it sounds simple, but it's actually a really brilliant bit of design.
Oh,
It's all about durability and speed.
right.
The housing is self-centering, and the ties let you install it super fast on pipes from 1 inch up to like 6.5 inches in diameter.
Ah, so no special tools, no drilling.
None. The focus is zero downtime. Anyone can install it correctly the first time in the field in minutes.
Okay, that makes sense. So it can survive the environment. But what about performance? When a tiny temperature shift could signal a huge problem, how does it actually perform?
The operational range is, well, it's extreme. You're looking at magnets 40 degrees air all the way up to 185 degrees Fahrenheit.
Wow.
But the real insight here is the precision. It's accurate to within plus or minus 1 degree Fahrenheit.
And that's crucial because it stops you from getting false alarms from just minor insignificant fluctuation.
Right. It maintains the integrity of the data. And speed is the other half of that equation.
How quickly can it actually detect a shift?
The response time is less than a minute. For a change of just plus or minus 2 degrees, that kind of rapid feedback is absolutely vital when you're monitoring, say, a critical cooling system.
A system where heat can build up and become catastrophic very, very quickly.
Dickens, yeah.
Now, there's one number in this data sheet that just blew me away. The reliability figure. Mean time between failures.
Oh, yeah.
Yep.
The MTBF, it's pretty wild.
It's 3,540,911 hours.
Which basically means it's designed to last over 400 years. You install it, and you forget about it. That completely changes the game for maintenance overhead.
And it uses a digital signal, which helps too, right?
Yeah. Yes, that's a huge advantage. It gives it a high resistance to any kind of electrical noise or interference, especially over really long cable runs.
And that brings us to connectivity. How does this sensor actually integrate into a network that might stretch across a massive campus?
The standard connection is super simple. It comes with a 7-foot CAT5e cable, and it's powered directly from the Environmux unit itself. It draws almost no power.
And with that standard cable, you can get it up to 1,000 feet away from the monitoring unit. That's already pretty substantial.
It is, but that's just the start. That's just with copper.
Okay.
If you hook this up to what they call the EFSC fiber converter, you can push that range up to 1.2 miles.
1.2 miles, 2 kilometers.
Yep, 2 kilometers from the main unit. And that capability is what allows for true enterprise-level monitoring. You can cover sprawling industrial complexes, remote pump stations, you name it.
So when you put this all together, what does it mean for you, the listener? We're looking at a sensor built not just for accuracy and durability, but for immense reach.
It's the silent workhorse. It ensures those vital pipelines, maybe carrying cooling water or critical chemicals, don't fail miles away from anyone who can do something about it.
A tiny $131 component preventing a multi-million-dollar disaster.
Absolutely. So here's something to think about. What kind of national infrastructure, spanning miles, needing minute-by-minute thermal data with this level of ruggedness and accuracy, what relies on components just like this to prevent a truly catastrophic failure?
You're talking about the things running right under our feet, aren't you?
The essential services that depend entirely on this one tiny, robust, and often forgotten link in the chain.